Alright, so we're back with some antiderivatives of natural logs, and we're going to start off with the integral of tangent x. Now, we've looked at the integral of secant tangent, we've looked at the integral of secant squared, but we haven't looked at the integral of tangent x specifically unless we look at it as sine x over cosine x. Alright, so if I don't know what the integral of tangent is, the first thing I'm going to do is try this. I'm going to try and change it to sine and cosine. Now, if you look at the fraction here, the derivative of sine is cosine, and the derivative of cosine is negative sine. So both of the derivatives are there, so the question becomes which one do you use? But what you got to remember is that cosine's in the denominator here. And so if you look at the sine x, the derivative of sine x is cosine, but technically this is 1 over cosine. Alright, so really looking at it that way isn't going to work. If you think about logarithms though, if I look at the cosine x being my logarithm portion, the derivative of my denominator is in my numerator. So this is a log function. This is the integral, the antiderivative would be the natural log of the absolute value of cosine of x plus c. Now if you think about it, if I were to take the derivative of this, the first thing I would get is 1 over cosine of x, which I see up top. But then I would take the derivative of cosine x, and that would be negative sine x. So I do need to put a negative out on the front here. Okay? And that is what you see down here in this list of trigonometric identities that you need to memorize. That's this dude right here. And, you know, we know the top one, sine of u du equals negative cosine of u plus c. That one we know. We know the integral of cosine is sine. But along with the integral of tangent, on the right-hand side, we also have the integral of cotangent. And so, looking at it the same way that I did in the warm-up up there, I would take the integral of cosine u over sine u, and that becomes ln of sine u plus c. Alright, we also have an integral for secant. You'll notice this isn't secant squared. So the integral of secant is the natural log of secant u plus tangent u plus c. Cosecant, same thing. The integral of cosecant is negative. Remember, because all the c's are negative. Okay, so the integral of cosecant u du is negative ln. And again, it looks very similar to secant u, cosecant u plus cotangent u plus c. And then we've got the integral of sine squared and cosine squared. They are very similar to each other if you look back and forth. The only difference being this minus and this plus right here. Okay, so you're going to need to know all these. Now these are different from these guys down here. These guys down here are just your typical antiderivatives. The integral of cosine of 8x. Well, I know that the derivative of sine would give me cosine, so this is sine of 8x. But then I need to divide by 8 to take care of the 8 that would come out. The integral of sine 11x dx, so the antiderivative of sine would be negative cosine 11x over 11 plus c. The antiderivative of secant squared is going to be tangent, so tangent of 4x. And we got to divide by 4 plus c. Cosecant squared, well, that's just cotangent of 1/2 x. And you got to be a little bit more careful here, because if I divide by a half, that's the same thing as multiplying by 2. So we need to multiply that one by 2 plus c. And then the integral of secant tangent is secant. The antiderivative is secant 2x. And we would have to divide by 2 here, plus c. Alright? So the rest of these guys, we're going to end up using those identities from up above here. And so you're going to want to get yourself some flashcards together and make sure that you know those. So looks like you got 6 new identities to work on today. Alright? Some of them aren't too bad though. Alright. So I'm going to take the integral of tangent of 3 theta. Now, again, I need to be able to look at this and determine when am I looking at something that's a little more complicated versus something that's not quite so complicated. So I know that the integral of tangent was not shown up there, but it was similar to what we saw in the warm-up here. So if I can't figure this out, then I'm going to change this to sine of 3 theta divided by cosine of 3 theta, and this is d theta. Well, again, now I can see that 1 over cosine 3 theta, that's going to be natural log, so that's going to be natural log of cosine of 3 theta. I'm going to throw my plus c on there just so I don't forget, but then I'm going to have to divide this by 3 because I've got the derivative of the inside material, and I've got the derivative. I would end up taking the derivative of cosine, which would be negative sine, so I need a negative out here to cancel that negative. All right. Secant of theta over 8. Okay, this is not secant squared, so I just need to be careful about that. And so this is going to be the natural log of the absolute value of secant theta over 8 plus tangent theta over 8. And because that's addition, those could go in either order and it really wouldn't matter. I'm going to do my plus c out here. But then I need to think about this, because if I were to take the derivative of this, I would end up with a 1/8. So I'm going to need to multiply this by 8 as well to cancel out the derivative of theta over 8. All right, what do we got next here? We got cotangent of theta cubed and 3 theta squared. So take a look at this. See the theta cubed here? There's the derivative right out front, 3 theta squared. So I know that the cotangent theta cubed is my main function, so I'm going to focus on that. And I'm wondering, should we even do a u sub here? We could do a u sub on this without too much trouble as well, but I don't think we need to here. So I'm going to rewrite this. This is the integral of 3 theta squared, and then I'm going to break cotangent up into cosine of theta cubed over sine of theta cubed d theta. And now again, hopefully once you get to this point, you can kind of look at the denominator and say, okay, what's the derivative of sine of theta cubed? Well, it would definitely involve a cosine theta cubed, and it would also have a 3 theta squared as a partial derivative. So again, you can see that by the numerator here, the numerator contains the derivative of the denominator, and so this is going to be a log function. So this is going to be the log of the absolute value of sine of theta cubed. Throw my plus c in there, and then I just go back and I check, okay, if I were to take the derivative of this, I would end up, and I'm actually going to write it out, I would end up with sine of theta cubed times the derivative of the bottom material, so that would be times cosine theta cubed, times the derivative of the inside material times 3 theta squared. So I can see that it works, and it gives me right back to where I started. All right. Let me see. This time we've got secant theta squared, sine theta squared. Well, I know that cosecant, did I say secant, cosecant? I know that cosecant is just 1 over sine of theta squared, so that would be equivalent, times another sine of theta squared, d theta. So this is kind of nice because the sine thetas cancel each other out, and I'm left with the integral of 1 d theta, which is just theta plus c. See, sometimes a little easier than it looks. All right. Next one. So this one I'm seeing, let's see if I can move this guy over. There we go. So this one I'm seeing a 1 minus sine squared theta in the denominator, which, you know, this, is the numerator cosine cubed theta the derivative of 1 minus sine squared theta? I don't really know, but I do know that 1 minus sine squared theta is equal to cosine squared theta. So I could rewrite this as cosine cubed theta over cosine squared theta, d theta. Cosine cubed over cosine squared is just going to be cosine of theta, d theta. What's the antiderivative of cosine? It's sine of theta plus c. That was easy, wasn't it? All right. Next one. All right, we have the integral of secant squared theta over 1 plus tangent theta. Now again, I need to look carefully here because this 1 might throw me off. But if you look at the denominator, 1 plus tangent theta, the derivative of 1 is 0, and the derivative of tangent theta is secant squared theta. So this is a log function here. This is going to be the natural log of the absolute value of 1 plus tangent theta plus c. Now, if you're not seeing that, just take the integral. The integral would be 1 over 1 plus tangent theta, so that would give me this, times the derivative of the inside material, which would be 0 plus secant squared theta, and there you go. All right. Oh, look at that. Are we done already? Assignment number 5 coming right up. Wow, look at that. See you on the next one.